friends, this is Devbrata Pramanik and you are watching my channel Physics Friends. Today we are going to find out the electric field at an axial point of a circular plate having uniform surface charge density. Look at this figure. Here this is a uniform circular disk having uniform surface charge density sigma. We are going to find out its electric field at an axial point P. First, let we consider an elementary area ds on this plate. The charge on ds is sigma ds. So, the electric field at P due to this elementary portion ds would be like this one, sigma ds by 4 pi epsilon naught r square. R is the position, curly r is the position vector of P, that is distance of P with respect to ds. Now d directs along this direction. The component d sin phi will be along this direction, that is will be in the horizontal plane. If we consider all the d sin phi components, then they all cancel each other. So we are left with the terms d cos phi. So the resultant electric field at P due to the entire disk would be summation over d cos phi. So total electric field at P would be like this one, sigma ds by 4 pi epsilon r square, which is d cos phi. But what about ds cos phi? ds is along this direction, that is along the axis, and phi is the angle between this position vector r and ds. So ds cos phi is nothing but ds dot r cap. So if we take the constant terms, that is sigma by 4 pi epsilon naught outside the integral, we get ds dot r cap by r square. But friend, this is nothing but a solid angle expression. We have discussed it in our previous class, and after integration over the limits of this disk, we get entire disk, we get the solid angle produced by this disk at P. Look at this figure. The solid angle produced by this disk at P would be nothing but sigma is equal to 2 pi 1 minus cos alpha. So this term will give us 2 pi into 1 minus cos alpha. If we put this, then we get the electric field at P as sigma by 2 epsilon naught 1 minus cos alpha. Look at this figure. If we take this point is at a distance z over the disk and the radius of the disk as capital R, then cos alpha takes the form z by root over z square plus r square. So the another expression of this field is sigma by 2 epsilon naught 1 minus z by root over z square plus r square. Thanks.